Okay, welcome back to the never-ending saga of fixing the tds540. Anyway, I wanted to thank everyone on the tech forums for helping me out. And there's been some suggestions that perhaps it is not the analog to digital converter. There's been some suggestions that it's the SRAM as well as the preamps. Now, in my previous video, I basically showed that the preamp seems to be fine. I looked at the signal going into the analog to digital converter, basically attenuated everything down to noise, and then proceeded to initiate the noise on the screen, the glitch. And there was no accompanying noise at the input to the analog to digital converter. My conclusion is that the problem lies beyond that point of the preamp, and probably is in this area. If you can see, let me get some light here. Here would be the preamp. Sorry, I'm doing all this on camera. Here's a digital analog converter. There's your demux, and there's the RAM for channel 4. All right. Anyway, the point of this is I hooked my trusty HP logic analyzer to the analog to digital converter, as you can tell with the pin connections there, the clamps. And I was going to run a test for you all, so you could take a look and maybe get back to me and tell me what you think. And again, from what the information I'm getting, I've done this already, of course, is that it still points in the direction of the analog to digital converter, which is rather a problem, because I don't know where to get a hold of another one unless I, get a board or something off of eBay. But nonetheless, we'll power everything up and have a look. As you can tell, that's the connection, and it leads to my trusty logic analyzer. All right, so we're going to turn everything on. Now this is upside down, sorry. Now, as you can tell, I get two fails. I get a fail on the acquisition processor interface and acquisition board. Used to be 3 fails, but now generally it's 2. Anyway, to set up the conditions, the vertical selectivity is set at 10 volts per division. And as you can tell, I do have a trace. And it does seem to work, but as you can tell, when you move the vertical position, all right, I get this very strange noise, and that sort of is detailed in the last video. Okay, so just give me a moment here to find it. Anyway, first, let's start this. All right, now, for illustrative purposes, if you look very closely, you can see this is the last 5, the most high-order bits in one of the 8-bit data words, and what it's showing. I'm going to then turn the sweep all the way to its lowest point, and you'll notice it's 0. I will then turn the sweep to its highest point, all once. So the analog to digital converter is working. Now, if we place the sweep at the 0 line, we're basically getting straight lines. They're all seem to be high, or at least mostly, for the most part, except for the most significant bit. Now, watch what happens. When we turn it to a point where we get glitches, this is what we get. And you can see the alternation, obviously. That's the waveform. This is what the screen looks like. Ever so slightly of a movement, and we're back to nothing. Now, my conclusion is that the digital analog converter is producing this noise. There is nothing going in. There's still a few channels, not channels, but there is still a few lines that come from the digital to analog converter, the DAC system, which is used for doing the offset, which does go into the analog to digital converter, which I want to check and see if it's creating any of this noise, but I really don't think so. So I just wanted to bring you guys up to date, and if there's any further suggestions, please everyone chime in and let me know what you think. I hope you're enjoying these videos, and thanks a lot for watching.